Hi, now I'm gonna explain the quiz 1 from Unit 1 of Physics 2 that says like follows. Mercury is poured into a U-tube, these are U-tubes, as shown in figure A. The left arm of the tube has cross-sectional area 1 of 10 centimeters square, and the right arm has cross-sectional area 2 of 5 centimeters square. 100 grams of water are poured into the right arm, shown in figure B. This is the figure B. So here we pour 100 grams of water. So here the height of the arm of the right rises. And we have first to determine the length of water column in the right, this height, arm of the U-tube. So we have to determine first this height, okay? Now, for determining it, we have to consider, I'm gonna write here, that density of water it's equal to 1,000 kilograms per meter cube. But here we have that the quantity of water poured was 100 grams. So we have to pass this to grams. So we have that 1 gram per centimeters cube. It's equal to the density of water. As we know, the density equals also to the mass over the volume. So we can see that here the mass that it's contained in the space we have to calculate are 100 grams. So we can write here 100 grams, that it's the mass, and the volume it's easy because we have here that this part is considered as area 2. So we can write here area 2 per the length, that it's the measure we have to calculate. Okay? Once we have here this part, we can use these two values of the equation to calculate the value of the length that we have to here. So we take the length, and this length equals to 100 grams over my area 2. That the problem says that the area 2 is equal to 5 centimeters square. So we can put here 5 centimeters square per our gram over centimeter cube. 1 gram over centimeter cube. Okay? Now, as we solve this equation, well, this equation, we can have that we have 20 centimeters length of the quantity of water that is poured inside the tube. Now we have to answer another question. The other question said, given that the density of mercury is, I'm gonna write it here, 13.6 grams over centimeters cube. What distance h does the mercury rise in the left arm? So here's the left arm. We have to calculate the distance from here to here. But we can see the image and notice that the same amount of liquid that goes from here to here, the same volume, it's the same volume that goes from here to here, okay? So we can name this part H2 in order to make the equivalence to get the height of this distance. Now that we know this, we can begin with that knowing that the area, the volume from here, this part, that is considered A2 times H2. This is the quantity that goes down. It's equal to the quantity that goes up. So it's equal to H, that is the height, per the area. So it's area 1 times the height. Now that we know this equivalence, we can get H2 out by saying that H2 equals to H1 times height over area 2. Okay? Then we can leave this for a moment and we can continue here using our formula for pressures. Okay? So we know that pressure 1 minus pressure 2 equals the density times gravity times the height. Okay? As we can see, we can use this formula in both sides to calculate some other equation in order to use this one in there to get our value of the height of H. Okay? As we can see, in the part of the water, we have that the P1 minus the P2 equals the density of water, that we have it already there, times the gravity times our length. The length is all this part, okay? Because it's completely all the part that is pushing all the mercury, okay? And here we have from the other side that pressure 1 minus pressure 2 equals the density of the mercury. I'm gonna write it like this. The mercury times the gravity times, here it's the important part, because we know that it's not only this part that it's affected, okay, this part. Also this part is affected. So we have to assume both parts, because both parts are affecting the movement of the mercury. So we can write it here, H1 plus H2, okay? The sum of both movements inside a tube. Then, once we have these two equations, we know that this part is the same. So we can put these two equally, okay? We have that the density of water times the gravity times the length, it's equal to all this part. The density of the mercury times the gravity times the sum of the heights. As we can see, we have here gravity of both sides. We cancel it. And now we can use this simple equation to get out what seems to be H. Okay. Once we have this value of H2, we can use our equation right here to substitute this value here. So we can have that the density of water times the length equals the density of mercury times H plus, and we write here A1 H over A2. Then from this part we can take out the H and write that the density of water times the length is equal to the density of the mercury times the h per 1 plus a1 over a2. Okay. Now here we have this value, and these two values. So we have to choose the h. So we have to take it out, and then you can have the h right here, and these two values go right here below. Okay? And then we substitute the density of the mercury, that is 13.6, as I wrote here. We substitute the area 1, that it's 10 centimeters squared, the area 2, that it's 5 centimeters squared, the density of water, that we have it right there, that are 1 gram over centimeter cube, and the length, that was the quantity that was established right there. Once we substitute our values, we will have that the result of the equation will be that the height equals to 0.49 centimeters. Okay? And as we can see, we have both results. So that is the end of the first quiz from Unit 1.